In this example, we're going to graph the function f of x is equal to 2 to the x power using a table. Let's first figure out what f of negative 2 is. F of negative 2 is going to be 2 raised to the negative 2 power, which is 1 over 2 squared, which is also the same as a quarter. You can plot these points now or later. It's up to you, but I'll go ahead and plot negative 2 a quarter on our graph on the right hand side. When x is negative 1, we're going to take 2 and raise that to the negative 1 power, which is 1 over 2 to the first power, also the same as a half. So my x value is negative 1, my y value is a half. I'll go left 1, up a half. 2 to the 0 power is an easy one. Anything to the 0 power is 1. So when x is 0, my y value, or f of x, is 1. So I'll plot the point 0, 1. 2 to the first power is also pretty easy. That's just 2. So when x is 1, I'll go up 2. 2 squared is equal to 4. Right 2, up 4. And 2 to the third power is equal to 8. So I'll go right 3, up 8. Some of you might be noticing something. If we take a look at this key point 0, 1, the vertical height is 1 and then becomes 2 and then 4 and then 8, or doubles. It's not a coincidence that the base is 2, and that indicates doubling. As we go to the left from this point 0, 1, all of the y values are just cut in half. So this y value is 1, now it's a half, now it's a quarter. Can you think of what the next one might be? If you said an eighth, you'd be right. You could keep plotting this as we would go towards negative infinity for x, but all of these values are just going to be half of what they once were, and so we're just going to be getting super close to the x-axis. But we'll never actually hit the x-axis, which is the same as y is equal to 0, and we won't cross over it. We'll just keep getting closer and closer. Now there's another part of this example, and we're going to take a look at some key features. So the graph that we just graphed is right here on the right hand side. I'll move that up a little bit so you can see a little bit more. And we're going to take a look at some key features. First of all, as we go from left to right, this graph is increasing, meaning that this function we would describe as being growth, and the growth rate is 2. The horizontal asymptote is the imaginary line that the function approaches or gets close to. On this side, it's the left-hand side only. And that imaginary line that the function gets close to or approaches is y is equal to 0. Some people will even graph the asymptote here by doing a dashed or a light line to indicate that's where the asymptote is. The domain are all the possible values of x, and if you look at the equation, you could substitute anything for x in here. Could be positive, could be negative, could be a fraction, could even be pi. So the domain is all real numbers. In interval notation, we represent that as negative infinity to infinity, meaning from negative infinity and everything in the middle all the way to infinity. The range, however, there are some y values that aren't possible on this graph. The purple graph here does not exist below the x-axis. It doesn't even exist for y is equal to 0, but it gets very close to 0. So we'll list the range with a parenthesis indicating we're getting close to but not exactly equal to 0. And then every positive y value as this graph continues up and up and up is possible. So the range is 0 to infinity. The x-intercept for this one is going to be none because the graph will never cross the x-axis. And we've got a couple problems here at the bottom to answer. So f is the y-intercept. If we look at the graph right here, the y-intercept happens to be 0, 1. Algebraically, you could take the equation, which is y is equal to 2 to the x power, and substitute a 0 in for x. That's supposed to be a comma right there. Getting a y value of 1. So we know that the y value for the y-intercept is 1. End behavior, as x approaches infinity, what do the values of y do? So if I have to be a point on this graph and I continue to the right, my y values increase, and they'll increase forever. On the left-hand side, though, as x approaches negative infinity, my y values, which are 1, then a half, then a quarter, then an eighth, then a 16th, then a 32nd, a 64th, and so on and so forth, those y values are actually just approaching 0, which is the same as your horizontal asymptote that we looked at before.